Hello, this is Matt from Mattini Apps, and this is part 5 in our Introduction to SwiftUI series. This video is the first of a couple of videos in this series where we start to take a look at using data in a SwiftUI app. In this video, we'll take a look at state and binding. To learn about these, we will put together the app that you can see on the screen right now. So we have some coding to do, so let's get to work. So for this, we will create a brand new Xcode project, which will be an iOS app, which we will call state and binding. Make sure the interface is SwiftUI, the lifecycle is SwiftUI app, the language is Swift, hit next and save it up somewhere nice and safe. When Xcode is kicked in, let's hit resume to start our preview. And when you can see this, we're all ready to go. So as I said, in this video, we'll take a look at state and binding in SwiftUI. Now, fair warning, I think this is a bit of a tricky topic when you first come to learn this. It's one of those where once you get your head around it, it's not too bad, but don't be disheartened if you have to watch this video or just a few bits of it a couple of times to fully get your head around. So, state and binding both relate to how we can use data in our app. So how we can take an integer, for example, and display it or change it from within our app. SwiftUI actually has a really incredible way of managing state. State in an app pretty much refers to all of the data at any one time. The state of a view is effectively the properties, so the integers, the strings, the booleans and so on that exist in the view and what they're currently set to. When one of these values change, something has been updated, so the state of the view will change. In SwiftUI, we can make our views display the data that makes up this current state. And if any of this data changes, these views will update automatically to reflect this. This is a really big deal. So for a real life example, we could have a text object that will show a score in a game. When that score updates, the text will update automatically to show the new score. If we were using UIKit, we manually have to set up a system that listens out for this data change and then manually update all of the UI. With this system in SwiftUI, we bind our views to data, and all of our views stay perfectly in sync with the data that they're showing. This is part of the reason why SwiftUI is a declarative way of coding. We just tell the code that a view should show a certain variable, and it will always show it whatever that variable is set to at any point in time. Honestly, it might sound kind of complicated, but it's not too bad when you see it in action. So to see this in action, what we will do, we will set up a number that will appear on the screen. In today's example, this number can be changed with a button or with a slider. Let's start with the button. So into our content view and into our body. We'll get rid of this example text for now because we no longer need it. Instead, we want a text object that will display a number that can update over time. So we will need a text object which will display some text. Now we don't have the variable for this yet, so for now we will just make it display 0. And as you can see, 0 is appearing over here on the screen. This is tiny, so let's make it a little bit bigger so we can actually see what's going on. Let's add a font modifier to our text object with a nice basic system font for today, size of about 100. There we go, it will show 0. So at the moment, this text object will display whatever is hard coded here. But remember, we want to be able to display a number that we can then change by using a button. So for this, we will declare a brand new variable to keep track of the number that we want to show. So outside of the body, but still in the struct, we will declare a brand new variable, so a piece of data that can change, called counterNumber. This will be an integer, which will have a starting value of 0. So this variable is a new property in the content view. So it's just holding a value that can change over time. Note, as we're setting a value here, when a content view is made, we don't have to pass this value in. This property already has a value. Now, rather than just displaying 0 in our text object, we can display whatever counterNumber is. So we'll take counterNumber and we put it in the string to show for the text. May have to hit resume, and as you can see, we're still getting 0 appear because counterNumber is set to 0. Now, we want to change the value of this property with a button, and this button will sit just underneath the text object. So let's pop our text object into a VStack, like so, and underneath the text object, let's make a brand new button. Now, when it comes to buttons and the slider, which we'll look at later on, in just a couple of videos, I'll have a whole video around the different kind of user interaction objects we can use, where we'll look at buttons in a lot more detail. But to set up a very basic button, what we would do, we will say button. We will give this a title that we want to display. And then we will give this an action. So we could, for example, print this button was tapped. So we have a button, which you can see here. Our title here is now displayed in the button, and anything we have between the curly brackets will happen when we tap on the button. It's the button's action. But as we said, we don't want any old action in the button. We want to add one to our counter number. So let's try and do that. In the button, let's take counter number and let's add 1 to it. As soon as we try and add 1 to counter number, we're getting this error, which says left side of mutating operator isn't mutable. Self is immutable. What does that mean? Well, pretty much properties in a struct like counter number can't really be changed. They're immutable. We can't really update them in the way that we're trying to do. Now this feels like this could be a huge issue. We have this property that we want to update, but we can't update it. What can we do? Well, this is where state comes into play in SwiftUI. What we can do, we can take our counter number and we can add a property wrapper to this to tell SwiftUI this is a property in our struct that we want to change the value of. Before we say var, we will say at state. This is a property wrapper to tell SwiftUI that we want to do something a little bit different with this property. It might take a second, but that error will now go. If not, try hitting try again. So as soon as we add at state, we are now allowed to update this property's value. Not only that, something else incredible happens. SwiftUI now knows that this property is part of the view's state and that its value can be changed. Because of this, whenever counter number changes, SwiftUI will now recreate the body object in the content view so all of the views work with the updated value. So just by doing this, our counter will work. Let's have a look. So what we can do over here in the preview, not only can we just see the UI, we can also use the UI to a certain extent. So find this play button above the preview, which will start a live preview, a preview that we can use. So now if we tap on our add one button, the number on the screen will update. Again, this all happened because of this state property wrapper that we added to this property. Now, as soon as counter number changes, in this case by adding 1 to it, but this could update in a number of different ways, our content view will see this and it will understand that our text view is trying to show this value. So it will re-render the view so the updated value is now displayed in the text rather than the old value. The view will stay fully in sync with value. We haven't had to manually update the view. That is handled for us. We've just said make a text object that will show counter number. Whenever it updates, the text object will be recreated for us to show this change. It's genuinely very powerful. It's worth noting now that whilst the state property wrapper is very powerful, it should be used on properties that belong to the struct, such as this integer. As soon as we start having some classes and some models control some data that our view will use, things are a little bit different. But we'll look at that in detail in the next video. But it's worth noting now that the state property wrapper should be used on properties such as this, where the property is owned by this struct. So we now have this property with the property wrapper that is being used in our view. This is a form of binding. Our view has been bound to this property, so it will stay in sync. But this is a form of one-way binding. This view will read this value and will update when it changes, but it can't write the value back. However, some objects need to both read and write the value. To see this in action, let's add a slider. So into our VStack, underneath the button, let's add our slider object. Now again, just like with the button, we're going to look at sliders in a lot more detail when we take a look at user interaction in just a couple of videos time. So this will be a nice basic slider for today. So what we want to do, we want to take this slider and we want to make it work with counter number. The problem is counter number is an integer and a slider needs a number with a decimal point. So what we'll do, we'll quickly make this a double. And because that'll make this text object do this, let's wrap counter number as an int in our text object like so. Best of both worlds. So now into the VStack, what we will do, we will set up a brand new slider to which we will pass a value and a range. Now the value for this needs to be a binding binary floating point. That's a bit different to just a normal number with a decimal point. To the point that if we tried to use counter number, it won't like it. So what we would do, we have to add a $sign to this. Let's finish setting up the slider and I'll tell you exactly why. The range is going to be the minimum and the maximum on the slider. And we can pass in step 1 so that our slider will go up in steps of 1. Let's also add some padding to this because this looks way too close to the sides. Padding will be horizontal only, left or right, with a padding of 10, just to bump it in just a little bit. So we now have a slider which works with counter number, but we've had to put this $ before it. The $ means that we're working with state and with binding, but that this is a form of two-way binding. The slider will both read and write the value of counter number. So when counter number changes, slider will update. It will read this value and it will update to reflect this. But, and this is the big but with two-way binding, when slider changes the property, because it's two-way binding, because of the $, we can now write back to counter number. It can read and it can write. So the $ means it's a form of two-way binding, and when we don't have a $, it's just one-way form of binding. We're just reading the value. Let's see this in action. Let's hit play to start off a live preview. Now, if we was to hit add 1 to update to counter number, as you can see, the slider is updating to reflect this change. The number is getting bigger, so the slider, because it's showing its value, will update to work its way across. But because of the two-way binding, when we slide this, it's also writing the value back, and because counter number is changing because the slider, our label is updating. Two-way binding. It can read and it can write. And that's what this $ means. Pretty cool, right? So that is effectively what state is in SwiftUI. We can take properties and we can mark them with this property wrapper. This property wrapper will let us update this value, and it will tell SwiftUI that when this changes, to re-render the body so our views all stay in sync. We have one-way binding, and an example here is our text object, which is just reading the value here. So when counter number changes, this text object is recreated with the new value. And we have two-way binding. That's what this $ here means. And with two-way binding, we can both read and write a value. If the value changes, the slider will update to show this change. It's reading the value. But because of two-way binding, the slider can also write to the value. So when the slider value changes, so when we drag this across the screen, counter number will automatically stay up to date with this value. The value will stay in sync with what the slider is set to. The slider is bound to our property, and the property is bound to the slider. It's two-way binding. When it comes to state and binding, there's one more thing that I want to show you. In part 4 of this series, we took a look at creating and using custom views, where we can pretty much take a view that we've made, we can wrap it up as its own view type, give it a name, and then use it anywhere that we want. With custom views, we can pass properties into the view to make them really customizable and really reusable. Now, sometimes you might want to pass down a property which has this state property wrapper. And if that's the case, things are just a tiny bit different. Let's see it in action. So for this example, we're going to make a custom view which would be a reset button. A nice basic view just to see this example. This reset button will sit down here at the bottom of the screen, and when we tap the reset button, the number will reset. So let's make a brand new custom view. So let's drop to the bottom of this file, underneath this struct, and we'll make a brand new struct, which we will call reset button view. This, again, will conform to view, and because it needs to conform to view, we need to provide a body where we can actually create our view. In this view, we will have a button, which will have the title text reset, and it will do an action. Now in this action, what we want to do, we want to reset counter number, which is our property with the state property wrapper. Now we learned last time that when it comes to custom views, we can add a property to our struct, and that will tell our code that we have to have that information when it comes to making our view. So what we could do is add a new property called counter number, which will be a double. But remember, this isn't any normal property. This is the property that we want to work with state. What we want to do is say if this is ever affected down here in this view, we want our content view to update. We want that state and that binding to work in this custom view. So because of that, what we will do before this property, we will add a new property wrapper, which is binding, like so. Now, when we try and make a reset button view, we'll be required not to pass in just a double, but a double which is linked up to state. And that's really important because now what we could do in the reset button is take counter number, this from here, and set this back to 0. Now we can pass on the property which is working with state into this view and have it work in the exact same way as if it was in the content view. If this updates, this property here is bound to the property that we passed in, making everything update and stay in sync. To see this in action, back to our content view and back to our VStack. And let's add a reset button view underneath our slider. When we go to initialize this, as you can see, we need to pass in a binding double. Now we can pass in counter number from here. This will be a form of two-way binding, so we need that $sign. This is really important because this number might be read and it might be written to from this custom view. So it has to be a form of two-way binding. So now we're taking this property, which is bound to our other views, and we're passing it down into a custom view so it can behave in the same way. Now, really important note, the property name in our custom view doesn't have to be the same name. So this property here and this property here, they can be named anything. I just sometimes like to link them up. It makes it a lot easier to read, down to personal preference. Let's hit resume. And we now have a reset button. Before we test this out, let's make it look a little bit better. So in the body, in the VStack, what it would do, just before the reset button view, let's add a divider, like so. And this will give us this nice line across the screen. And then these are looking really, really squished together. And I want this reset button down the bottom. So what we could do, before the divider, let's add a spacer, which will give us a big old gap here. But that then pushes this stuff to the top of the screen, which I don't want for today. So to keep this nice and simple, let's add one more spacer to the top of our VStack to bring this back down. And then we could, if we're being picky, add a little bit of padding underneath this reset button to bring it up just a little bit from the bottom of the screen by adding some padding at the bottom of perhaps about 8, just like so. I think that looks good enough for today. But anyway, let's test this out. Let's hit run on our preview. So now in our custom view, we are passing down that property, which is bound. So we could update it here. All works like expected. But now when we hit that reset button, because the property in the custom view is bound back up to our state, if we hit reset, our content view will update in the exact same way, almost as if this wasn't in the custom view. So that look at using this in a custom view is a little bit of an extra bonus at the end of this video, and I hope you find it useful. But that brings an end to our look at state and binding in SwiftUI. And that wraps up this video. So as always, leave any questions or any comments down in the comment section. If you enjoyed watching this video, which I really hope you did, make sure to hit that like button, hit subscribe, and once again, thank you for watching. I'll see you next time. Goodbye.